everyone, Rhoda here with a Jack capsule about trigonometry. We're going to talk about how to convert from degrees to radians or from radians to degrees if you need to do that. So in front of you here, you have some very common angles that you're going to run into in your calculus class. And right now they are expressed in degrees. That's probably the notation that you're most comfortable with. So we've got 360 degrees, 180, 90, 60, 45, and 30. How do I switch from degrees to radians? Well, radians are just another unit of measurement that we can use instead of degrees, and they are the more common one in your calculus classes, and in advanced mathematics in general, we tend to use degrees. So all you really have to remember is that when you do a full turnaround of a circle, that's 360 degrees, but it's also equal to 2 pi radians. If you remember that one full turn of the circle is 2 pi, then you can figure out whatever angle you need based on the fact that it's going to be proportional to the angle in degrees. So if one full turn around the circle is 2 pi radians, what about 180 degrees? 180 degrees is half of the full way around a circle. So it's going to be half of 2 pi radians. That means that 180 degrees would be pi radians. That one's pretty easy to just pick up right away. But in general, what you could say to yourself is that your angle in radians is going to be the same proportion of 2 pi as the angle in degrees is for 360. Since 2 pi radians is the same as 360 degrees, these two ratios have to match. So you can use that to figure out whatever one you want. Sometimes the angle might be easier to figure out through common sense. So if I was looking at 90 degrees, I might say to myself, well, 90 degrees is 1/4 of the circle. So in radians, it's going to be 1/4 of my 2 pi radians. But when in doubt, you can use this ratio here. So here are my 6 angles again. If you need some practice, please pause the video here and fill these in radians. So just to remind you, we've got 360, 180, 90, 60, 45, and 30. That's what I want to convert to radians. When you unpause, I will solve it too. Okay, so I filled in the ones that we had already discussed. 360 degrees is the same thing as 2 pi radians. 180 degrees is the same thing as pi radians. For the other ones, for the practice, I will use this ratio formula. So for 90 degrees, I would say whatever proportion of 360 90 degrees is, the angle I'm looking for in radians, I'll call that theta, is going to be the same proportion of 2 pi. Based on that, I could solve this pretty quickly. 90 over 360 is 1/4. And then if I multiply the 2 pi over to the other side, I would get 2 pi over 4, which is the same as pi over 2. So pi over 2 radians is the same thing as 90 degrees. You probably get the idea by now. I'll do all the rest as well, but as soon as you get the point, you can move on to the next video. So next one, we had 60 degrees. Whatever proportion of 360 that is, my angle in radians would be the same proportion of 2 pi. Well, 60 over 360 is 1/6, and then again, I would move the 2 pi to the other side by multiplying, so I'd get 2 pi divided by 6 is equal to theta, which I can reduce, and that gives me pi/3. So 60 degrees is the same as pi over 3 in radians. Next one was 45 degrees. I'm covering the most important cases here. These are the values on your unit circle that you're going to need to know sine and cosine for. So 45 degrees, once again, 45 over 360 is equal to my angle in radians over 2 pi. So now I can solve that. I would get 90 pi over 360 is equal to theta. And if I reduce 90 over 360, I get pi/4 is equal to theta. So 45 degrees is the same thing as pi/4 in radians. A little separation there. Last one is 30 degrees. I could solve this in 2 different ways. I could do the ratios that I've been doing this whole time, or I could say to myself, well, 30 degrees plus 60 degrees gives 90. 60 degrees I know is pi/3. 90 degrees I know is pi/2. So that means that 30 degrees in radians plus pi on 3 has to give me pi on 2. So based on that, I could say to myself that the angle I'm looking for is pi over 2 minus pi over 3, which if you give it a common denominator works out to pi over 6. Or of course, you could use the ratio that we were doing before. So 30 degrees is the same as pi on 6 radians. That's it. That's all you need to know about converting from degrees to radians. If you need to go the other way and convert from radians to degrees, you would use that exact same ratio, just filling in the angle in radians and solving for the angle in degrees. Hope that helped. See you in the next video.